Right now, we're talking about percent change, which comes up a good amount on the digital SAT. Here's how you can use this lesson. First, try the questions on your own. One way you can do that is you can click on the link in the description to access a worksheet and a key, so you can find out what questions you actually need help with. Another way to do the same thing is to pause the screen every time you see a new question. Try that question first, and then maybe skip ahead, check your answer to find out if you need to see the video explanations to this question. Remember, there's no such thing as luck on the SAT. You have to work at it, and you have to use a teacher whose lessons align well with the actual test. And that's exactly what we're doing here at Grateful. Here's our first question. The weight of a yacht was W tons. Over time, its weight increased by 17%. Which expression represents its new weight in tons after the increase? What you need to know about percent changes is that they start at 100. So percents are different than other numbers because if nothing happens percent-wise, then you're at 100%. So right now, you're at 100% of your body weight. If you were to lose weight, you'd lose from 100, or gain, you'd gain to 100. So in this question, the weight of the yacht increased by 17%. So just imagine something goes up by 17% or down by 17% from 100. So it would go up to 117% or down to 83%. Now, to turn a percent to decimal form, you move the decimal over 2 spaces. So 117% becomes 1.17, or 83% becomes 0.83. So because this one involved an increase, the answer is 1.17. We'd be taking the original weight and simply multiplying it by that number. Now going to our next question. A person was on a diet and lost 23% of her weight. If her original weight was W pounds, which expression represents her new weight in pounds after the weight loss? So, once again, percents start at 100. From there, it could go up 23% or down 23%, either to 123% or 77%. In decimal form, this would be 0.77 and this would be 1.23. So because this question involves a loss of 23%, it's going to be this one. We're going to be taking our number W and multiplying it by 0.77, which is answer choice A here. Here's our next question. A cell increased its potassium content by 0.52%. If the original potassium content of the cell was P milligrams, which expression represents its new potassium content in milligrams after the increase? Well, now we're getting into more awkward percentages, so we just need to stick with what we're doing and be really solid in that. Start at 100, and from there, we could have gone up by 0.52% or down by 0.52%. 100 plus 0.52 is easy, 100.52%. And 100 minus 52% is a little tougher. We'd have to really think about the math on that, but that would come out to 99.48%. Now, to move it into decimal form, because these are more awkward percents, let's just use a regular model. For instance, if we had 56%, that would be 0.56. So the decimal is moving 2 spaces to the left to get from percent form to decimal form. So if we move it 2 spaces to the left on both of these, we'll have 0.9948 or 1.0052. So in this question, because we're increasing by the 0.52%, that means we're going to select this one, 1.0052 times the original number, which was P. So the answer here is A. Now going to our next question. Here, the percent is getting even more awkward. As a baby grows into an adult, his height increased by 318%. If his height at birth was H inches, which expression represents his height in inches as an adult? So, for percent changes, you start at 100, and then you go up or down from 100. So plus 318% would be 418%. Minus 318% is a little too complicated. we don't really need to think about that one in this situation. But as we said earlier, you can think about what you would do with an easier percent. For instance, 56% turns into 0.56 because the decimal moves 2 spaces to the left. Therefore, 418% would become 4.18 if you move the decimal 2 spaces over. So we have 4.18 times the original number, which was h, and that's answer choice A here. And now we're moving over to a different question type because we're not being asked what we would multiply the number by, but we're being asked what the final number is going to be. But it's just kind of a twist on the same idea. So let's read the question. A scientist studying an ant colony counted the number of ants each day for 46 days. Initially, on the first day, there were 830 ants in the colony. By the end of the study, the number of ants had increased by 22.53%. How many ants were in the colony at the end of the study? So we're seeing that our number increased by 22.53%. So just like on the other questions, you start at 100% and you imagine what would happen if you went up by 22.53% or if you went down by 22.53%. So going up is easy. It would become 122.53%. Going down, it would become 77.47%. And now we can think about moving both of those into decimal form by moving that decimal 2 spaces to the left. So 0.7747 or 1.2253. So whatever the original number is, we just found out because we're increasing, we need to multiply it by 1.2253. So on the first day, we had 830 ants, and that's the number we need to multiply. So 830 times 1.2253. So let's go ahead and multiply that out. 830 times 1.2253. And that gives you a number that's essentially 1,017. So our answer here is C. Now going to our next question. A waste processing center initially handled 5,283 tons of waste per day. Over time, the amount of waste processed increased 467.86%. What is the total amount of waste in tons processed per day after the increase? So on this question, once again, we're increasing by a certain percent. So the rule for that is to start at 100 and then increase or decrease by whatever we have to increase or decrease by. In this case, it's 467.86. Because we would be decreasing by a bigger number than 100, that's a little complicated and we shouldn't even look at that side of things. So now if we go ahead and add, we'll have 567.86%. And putting that in decimal form, that's 5.6786. So that's the number that we need to multiply our original 5,283 by. So let's do that. 5,283 times 5.6786. And that comes out to 30,000, which is answer choice C here. Now going to our last question. In a certain year, there were 220,000 reported cases of polio in the U.S. Due to medical advancements and widespread vaccinations, the number of cases decreased by 99.64%. What is the approximate number of polio cases per year after the decrease? So once again, we have a percent change. So we'll start at 100. And from there, we could have gone up or down by the 99.64%. If we go up to 199.64%. If we go down, 100 minus 99.64 is 0.36. So these being more awkward percents, it doesn't hurt to just think about a regular percent. For instance, 56% would become 0.56. If you move it into decimal form, you'd take that decimal and move it 2 spaces left. Same thing here. This would be 1.9964. And this, we need an extra 0, and it becomes 0.0036. So to decrease a number by 99.64%, we need to multiply it by 0.0036. So let's go ahead and do that. 220,000 times 0.0036. Let's do that on the calculator. So we have 220,000 times 0.0036, and that comes out to 792. So let's write that here. And that's approximately, in other words, you can generalize, it's approximately 800. Thanks for watching this lesson. Grateful produces SAT lessons that are meant to closely align with what you see on the actual SAT. Be sure to become a member for access to our solutions to the entire SAT question bank. Thanks so much and have a great day.